Okay, I assume we have a design that is to be simulated, that it's ready by now. So what we'll do is we'll just open the part. Let's save it on desktop, escape, scaffold, and that part to open. Okay, we'll start from here. So you can do either like right click here, start with a new FEM and simulation, or just click here. It works both the ways. Then we'll just set it to use all bodies, polygon to high, and change this to nastrran structural, and this is set to be none. Then click OK. Then it creates two files actually for us. So the first file is .fem file and the second one is .sem file. So .fem file, we just assign the materials and create mesh in the .fem file. This is apparently connected to this in some way. So if you mesh here or assign materials here, it will be connected to the simulation. So let's go to FEM for now. We have materials. You can create materials and manage the materials here, but you don't assign them here. To assign the materials, you need to go to more and assign the materials. Select the body, and for now I'll just use 6061. Alright, so the material is assigned. Close it. Then we'll start with the mesh. For simplicity purposes, I'll use a weaker mesh or a coarser mesh for this part. I'll apply it. It takes a while. I'll continue after it completes. Okay, now we have the mesh ready for us to use it. Now we'll just move to the simulation part. If you can see here, the mesh controls, the mesh is connected here from the .fm file. It's connected over here. Then we'll start with applying the loads. Let's go by a Z direction load. Let's do it in the view in the front direction, move it, select the top faces like that. Yep. And let's say a load of 1000 newtons with a given direction downwards. Let's select that. Yep, it did. We have the direction, we have the load. We just click apply. There's a load. Then we'll have to put some constraints to it. Let's go with a fixed constraint on the bottom piece. Right click, go in the view, front, move it, select the bottom pieces. Guess that's good enough. Apply. We have our constraints there. Then we need to create a set. So we create a set from here. Solution 1, nastrran structural, yeah, everything is good. Just create the solution. You'll see that it's adding something here. We'll just click OK. Then what we need to do is the constraints that we created are currently inactive. So we just move the constraints from here to here and it becomes active. Similarly with the force, it becomes active. We need a force here as well. So everything is active now. Now what we need to do is just go to solve, go to edit solver parameters in the parallel thing, just change that to 1. So we'll like start computing in parallel, like computing parallelly using your multiple cores. Then we'll click on OK and start it on the bottom screen apparently. I'll just try to move it. It will go through all that steps. Let me just restore that. It's going through the steps here. It will tell us when it's completed. Then we just go in and look at the results. That's basically it. Okay, now you can see that the job is completed. We'll just close it if it allows us. We have the results here. Just open that, go to structural displacements magnitude. So that's our displacement. You can see the maximum displacement here at some points, and it's about 0.06 mm. That's pretty good. Go to elemental or nodal stress. Just click one like this, and it's about 922, but we don't see a spot where it occurs. Maybe at some ends of your nodes. It might be concentrated as it is a coarser mesh. If you go with a finer mesh, you will get better results. So that's it basically, and we need to do this for every other design. Thanks.